Hi, this is page 3. Okay. Blah, 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 blah. Okay, I put the metal in this water. The initial volume was, this is 50. This is 60. There are 10 spaces between 50 and 60. That means each space is 10 divided by 10. 10 divided by 10 is 1. Each space is 1 milliliter. Okay? 50, 51, 52. The bottom of the meniscus is not quite at 53. So I say 52.9, maybe. So 52.9 milliliters minus, this says after the metal is inside the graduated cylinder. 70, 75, 76, looks like 76.0. Calculator. 76 minus 52.9. 23.1. 23.1 milliliters. Don't forget to guess the last digit. That's 76.0. It's not 76. It's 52.9. It's not 53. Okay? What is the density? Oh, I forgot to ask the density. Sorry. Here, let me show you how to find the how to identify the metal using the density. On the exam, I will ask you to calculate the density, and I'll ask you for the number. But anyways, the mass from page 2, the mass was this, and then from up here, the volume is this. Density is mass divided by volume. It's 10.92, but there are only 3 significant figures, so it's really just 10.9 grams per milliliter. Who's like that? Ooh, silver is close. Who else is close? Ooh, lead is close. So it could be silver or lead. Okay? Now we have to find the heat capacity, because I don't know if it's silver or lead. The metal goes in the test tube. In test tube. What is missing? The thermometer is missing. Where should that missing piece go? The thermometer goes in the water. And the water's in the beaker. When should you stop heating? You should stop heating at about 3 minutes after water begins to boil. Why? Because when the water boils, you know that the temperature is going to stay the same, because boiling water always stays at the same temperature, somewhere around 100 degrees Celsius. It may be 101, it may be 99, but whatever temperature it is, as long as the water is boiling, the temperature will stay the same. Now, why is that important? It's because you want the heat to go inside the metal. So if the temperature is changing, you will never know the temperature of the metal. The temperature has to stay the same for a few minutes, so that you can be sure that the metal is at the same temperature of the water, and therefore, because the thermometer is in the water, you know what the temperature of the metal is. Okay, so this water boils at 101. Okay, so that means that was 101 is the initial temperature of the metal. This is the initial temperature for the water. This is the final temperature for the water. What is this? 20. There are 10 marks, or there are 10 spaces between 20 and 30. 30 minus 20 is 10. There are 10 spaces. 10 divided by 10 means each space is 1 degree Celsius. 20, 21, 22, 23. Is this 23 degrees Celsius? No, it's not. Because this instrument lets you guess the last digit. Let's see. There's a straight line at the top of this calculator, you see? Ooh, it's not 23. It's more like 23.1. What about this? 30? No, this is 30. 35. 35.0. Okay, watch that. It's not 35. It's 35.0 because this is a good thermometer. Okay, let's find the difference. 35 minus 23.1. 11.9. So, the change in temperature is T final minus T initial. 35.0 degrees Celsius minus 23.1 degrees Celsius. And that was 11.9. 11.9 degrees Celsius. That was for the water. So, this is a nice formula. In your lab manual, they use different letters. They use S for the instead of the C, but that's okay. You can use whatever letters you want. The mass of the water was this. So this is for water. This is for water, okay? Water. The mass of the water was this, 79.1. The C for the water. I will give this number to you. I'm sorry, I forgot to put it on the practice exam. However, you can find it in your textbook or even in the lab manual pages that you worked on for this lab, and also on Google. But I will give it to you on the final exam, of course. And then delta T. That's this one right here. Okay? $36.70. What are the units? Joules. Okay? That's how much energy the water absorbs. That's it for this page.